with my front suspension being used for all suspensions. It looks like the front suspension with a modification of 2 parameters. I could very easily reuse that thing as the back suspension. So you need to go through there and really say, what are the similarities? Can I design one screw and by changing 2 parameters, have it represent all the screws? So just by studying out component by component, subassembly by subassembly, you should be able to determine how to attack the modeling of this part. Analyze the order of the assembly. By doing that, you will very likely be led to the underlying skeleton that needs to be put in place to control each assembly, each subassembly. Okay? If you look at this thing and say, how did it come together? Where did it interface? Where are the mating conditions? By studying that out, you will say, I know exactly what the skeletal representation has to be. You're going to want to make sure that you fully understand the mating conditions allowed on your CAD system. So this is a collection of the mating conditions off of NX. The CATIA mating conditions are called slightly different than this, and there's, I think, 4 additional ones that NX doesn't have. What you're going to want to do is you're going to want to make sure that you understand exactly how those mating conditions work. Generally, on your CAD system, you can find a mating condition table that says, if you've got 2 components, the one component has a line, and the other component has a point, and I want to mate a point and a line together, then it will tell you exact point and line. It'll tell you exactly which mating conditions allow you to do that. And there may only be 1 mating condition that you can go and use. There may be 5 mating conditions. But only one of them is going to be the best to try and implement on that particular mate. Okay? So this is a map of all the different kinds. It's only the bottom because the other side is exactly the same. But you need to make sure that you kind of study that out and you talk about it as a team. Am I going to use a face-to-face mating condition with an offset? Or is it going to be face-to-face because it needs to be glued together? I think most of us understand what a bottom-up approach to assembly modeling is. We create every component. We hand 2 of those components to John, and John builds a subassembly number 1. We had 2 more components to Sally, and Sally builds a subassembly number 2, doing all of this mating condition, okay? And so on and so forth. Those subassemblies then get handed to another person, and that one person individually kind of puts them all together, okay? The method, which I think we fully understand. What are the benefits to this approach? Are there benefits, and if so, what are they?
It's easy to set it up and start doing it. Thanks for the workload.
Everybody can start today working on a part, because we haven't had to think about how they're going to go together or anything like that. We can immediately start modeling. We have no worries. We're not even concerned about will they fit together, will they go in there right, or anything like that. We just launch off and start modeling. Okay? So people can immediately start working. So that's one benefit. Are there others?
Going with that, you don't have to figure out parameters. You don't have to figure out any mathematics. You don't have to figure out any relations. You can just jump right in.
Okay, that is true. That goes along with immediately being able to start. Are there disadvantages to this? And if so, what are the disadvantages?
It's very difficult to change parts, especially when you have assemblies already assembled.
Yeah. If they're not shared relationships, parameter one affecting 3 or 4 parts, if that's not kind of shared, I change a size on one part, it's not gonna have any effect or anything on the other part. Unless we do some linking, but right now we're not talking about that. We're just talking about kind of a bottom-up brute force, make the number. So it is hard to adjust or tweak or change. It's very difficult to kind of do it as a family of parts.
You would be redoing a lot of work by modeling, parts that are reused several times.
Yeah, so the reuse has not been studied out, and so the chance of you duplicating or making the same part over and over again, that does happen. In a lot of my approach. You try and avoid it, but it's pretty tough. A top-down approach, you start in the assembly, you build up a skeletal assembly, which is kind of uniquely, I think, taught here at BYU. We've been doing this since probably 15 years ago. We've been kind of teaching a top-down skeletal approach. You build a very robust skeleton in the master assembly. You pair off a portion of that skeleton that represents the skeleton for assembly 1, sub-assembly 1. You pair off another part of that that represents the skeletal structure for sub-assembly 2. You pair off another part of that for sub-assembly 3 and so on. And then in the sub-assembly, you take elements of this sub-assembly skeleton and you push it into each part, the appropriate piece of it. So, is that a good thing? Why is it a good thing? Well, if you have massively large assemblies that you want to be able to tweak and adjust and update and reconfigure, it's an excellent approach to being able to do family of part design or family of products design. How is the method done? This is a repeat, I think, of what you received on Thursday, but I think it's worth kind of going over, and if you have questions or confused about something, we take a minute and talk about it, because we want you to hit the ground tomorrow or Friday and actually be able to understand this and be able to do it easily. So what you do is you open the master assembly file. It's a blank file, there's nothing in there other than origin, okay? And with that, the first thing that you do is you set up key parameters. And there's only a handful of these things. It is the length of the car, it is the track width of the car, it is the ride height, or overall height of the car. You pick a very small number of parameters that are going to drive the overall update of your vehicle. You come along from that and you build